A very good evening and Assalamualaikum to our lecturers. So today we're gonna explain about our lab 7, which is system response, frequency response. So we are from group 16, which is from me. I am Yusra, and also I have Aiman. So in this lab, normally we separate our lab like by lab. One people do the med lab and another one do the report. So we change by every lab. So for I'll upload the YouTube link later on. So proceed. For this lab, we actually in short, we actually determine the frequency response of a system using an approximate and actual Bob plot. Before that, we just went to the equation given. So in this lab, let me check. Okay, so this is this is the lab sheet given. So we are given this equation for transfer function and also the block diagram for it. So we have two part, which is part A and also part B. So it's asks for us to find the gain margin, phase margin, stability, and approximated and actual dot plots. So basically we've we've done the calculation, and we also break the frequency of the ball plot uh, at 2 radians, 5 radians, and also 50 radians per second. So um, we set K at 500 so that we want to start the bot plot at 0 dB. Um, this is the calculation that we have done. So basically, we convert the transfer function equation to the normalized value, and then we set the k to 500. So this is the equation that we got after that. And then from the word plot, the word plot that we've drawn here, uh, we evaluated the gain margin was 28 dB and the phase margin at 105.75 degree. So that's for the gain margin and also for the phase margin. That's for the theory part, and then we proceed to the simulation by using MATLAB. So as stated here, the number is 500, which is the value of k, and we just add the value of the -5, -2, and also the -50, which is our break frequency, and then we get our results here. So at 19 we got a 32 value. So as stated here, let me see. Yeah, so it's stated here that the gain margin is 32 dB. And from the graph, the frequency is 19 radian per second, which is here, and that's overall. So uh, we learn to determine the frequency response of the system using the approximated of actual dot plot, and besides that, we also learn how to evaluate the gain margin and also the phase margin to approximate the actual dot plot. So the results got slightly different due to the simplification of dot plot to a sequence of straight lines compared to the actual one. So um, so from the result that we obtain, we also conclude that the system with greater gain and phase margin can withstand greater changes in system parameters before becoming unstable as a result for part B, which with greater gain and phase margin had wider range value of K that makes the system stable. So I think that's all from me. Thank you to Aiman for helping me to complete this lab together. And thank you, Doctor, for watching our video. That's all from us. Thank you.